Hey everyone, and welcome to today's Explainer. I am absolutely thrilled you're here with me. We've got a really fascinating journey ahead of us today as we dive into this source material. We're going to be blending the beautiful logical patterns of mathematics with real-world motion and then wrapping it all up with moral purpose. I know, right? It sounds like a massive task, but honestly, I promise you, by the end of this session, you're going to look at something as simple as a tossed ball or even a flying toy rocket in a completely new, mathematically powerful way.
Okay, let's dive into this. Here's our roadmap for today. We'll start with patterns in creation, then meet the vertex form, move into modeling real-world motion, give you your turn to practice, and finally finish up with vertex, virtue, and peace.
Section 1. Patterns in creation.
So, before we look at a single number or variable, the source material actually establishes this really big picture. Mathematics isn't just, some set of random rules invented to torture middle schoolers. The curriculum posits that math is quite literally the underlying language of the patterns we see all around us. To frame this, the source uses a quote from Proverbs 3:19. By wisdom the Lord laid the earth's foundations, by understanding he set the heavens in place. This establishes a pretty profound philosophical premise for the HeroesMart curriculum. Basically, the idea that creation isn't just random chaos, it actually follows logical patterns, and following that logic, forming algebraic equations is seen as a way to reflect and even uncover that hidden architecture.
Okay, so you might be wondering, why does this matter to you right now? Let's bring this abstract math right down to reality. Have you ever wondered how engineers design that perfect stomach-dropping loop on a roller coaster? Or how developers program a character's jump in a video game so it actually feels realistic? Or even how sports analysts break down a perfectly arched basketball shot? Well, they use the exact quadratic formulas we're learning today. These formulas are literally vital tools for modeling motion. Mastering them isn't just about passing a math test. It's about building a solid foundation of problem-solving confidence that you're going to use in science, in tech, and honestly, just in real life.
Section 2. Meet the vertex form.
Now, what's really interesting about this slide is the sheer power of this single equation, y equals a times the quantity x minus h squared plus k. This right here is the vertex form. In this formula, the variables h and k represent the vertex. That's just the absolute highest point of a jump or the lowest point of a dip. The variables x and y simply represent any other point that the object passes through on its path. What makes this whole setup so brilliant is that it lets you work entirely backward. If you just know the peak of an object's flight and then one other random snapshot of where it was, boom, you can build the complete equation of its motion. It really teaches us that with just a little bit of data and the right structure, you can figure out a whole lot.
Moving on to Section 3, Modeling Real-World Motion.
Let's look at our very first example here, a ball toss. Imagine you toss a ball, and it reaches its absolute highest point exactly 2 seconds in at a height of 6 feet. Well, that gives us our vertex right there, 2, 6. We also know that at 3 seconds, it dropped down to 5 feet, so that's our point, 3, 5. Let's methodically walk through this, step by step. Step 1, we take our vertex form and plug in the h and k. So we get y equals a times the quantity x minus 2 squared plus 6. Step 2, we need to find that missing a value, right? So we plug in our other point, replacing the x and the y. Now we're looking at 5 equals a times the quantity 3 minus 2 squared plus 6. Let's do the math inside the parentheses. 3 minus 2 is 1. 1 squared is just 1. So 5 equals a plus 6. Step 3, we just solve for a. Subtract 6 from both sides and we get a equals -1. And just like that, we have everything we need for our final equation. Y equals -1 times x minus 2 squared plus 6. You guys just mathematically modeled physical reality. How cool is that?
And this brilliantly illustrates how the exact same logical steps apply across completely different scenarios. Take a toy rocket on one hand. It peaks super high at 4,20 and then drops incredibly fast to 6,4. If you run those numbers through the exact same steps we just did, you'll find your a value is a really steep -4. Now, take a skate ramp on the other hand. It starts high at 0,10 and curves down gently to 2,6. Run those through the formula and you get an a value of -1. So whether you're blasting a rocket into the sky or dropping into a half-pipe on a skateboard, the math remains totally reliable, consistent, and honestly beautiful.
Section 4. Your turn to practice.
Okay, So here are the 5 problems assigned for your independent practice, from basic coordinates to modeling a soaring baseball and even a plunging diver. I want you to feel totally confident going into this. You now possess the exact blueprint needed to conquer every single one of these. Remember your steps. Plug the vertex in for each and k, plug the random point in for x and y, solve for a, and write out your final equation. Take your time with it, trust the process, and trust those logical patterns.
And finally, Section 5, Vertex, Virtue, and Peace.
So the Hero Smart Academy Godly Learner series intertwines education and morality. Their core philosophy is simple, but really profound. Education without morality will hurt. Think about it. Just as we use the vertex formula to predict the physical outcome of a tossed ball or a launched rocket, the curriculum teaches that we rely on morality to guide the long-term outcomes of our actual lives. The idea is, if you have the math skills to build a rocket, but you completely lack the morality to use it for good, the outcome is ultimately going to be destructive.
To frame this concept, the curriculum looks to Romans 8, 6-7, which promises peace of mind to everyone who keeps their mind spiritual. The series teaches that when you engage with education, even something as seemingly, secular as algebra, with a spiritual, morally grounded mindset, it doesn't bring anxiety. It brings peace. It really serves as a thematic bookend to the lesson presented today, bringing together the logical foundation of math combined with the spiritual foundation of virtue.
So all of this leads us to a really crucial point, summarized in this final question directly from the source material. What is the point of being smart and supposedly educated if we continue making bad choices that hurt? As you master these quadratic foundations, the challenge presented to you is to simultaneously master your moral foundations. Try to recognize the vital connection between the academic power you're gaining right now and the moral responsibility you carry moving forward. Thank you so much for joining me in this explainer today. Go out there, crush those practice problems, make some great choices, and I will see you in the next one.